Hello, I'm Yuzuru Kitamura from Tokyo University of Agriculture and Technology. Now, I start my presentation about the strategy of my agent, EpsilonGreedyAgent. Here's the content of my presentation. I'm going to talk about my agent's concepts, proposal strategy, acceptance strategy, response strategy, and evaluation in a simulation. To begin, I will explain my agent concepts. My agent is based on the BetterThink agent published on the tutorial Developing an Agent for SCML 2024 OneShot. Because of narrow price range in this year's rules, my agent will ignore price and focus only on quantity. This agent learns past transactions and utilizes learned by data by using epsilon greedy strategy, commonly used for reinforcement learning. I will now explain the proposal strategy. EpsilonGreedyAgent uses two different ways to distribute needs. The first is even proposal and the second is uneven proposal. Needs here refers to the quantity of a transaction determined by the exogenous contract. Originally, BetterThink agent distribute needs almost randomly. Strictly speaking, at least one was distributed. This figure is one example. If there are 6 amounts of exogenous contract, BetterThink agent will distribute 3, 1, and 2 respectively. In other cases, this might distribute 4, 1, and 1. When even proposal strategy is used, this agent offers even quantities to all my negotiators. This example, it distributes 2, 2, and 2. When uneven, it distributes 1 to the others and then distributes all the remainder to the target. The target is a negotiator most likely to accept my proposal. On the following slide, we will see the strategies for finding targets. To find a target, this agent counts the number of times the first proposal was accepted for each negotiator and calculates the percentage step by step. Since the first proposal is only once per step, the exact percentage is not required at the beginning step. There is the following trade-off between even and uneven proposals. More even proposals result in unacceptable and inefficient offers. More uneven proposals slow down the identification of the target. To handle this trade-off, my agent used the epsilon greedy strategy. We do exploration with probability 1 minus epsilon, and we do exploitation with probability 1 epsilon. Epsilon varies according to this equation. We will now look at acceptance and response strategy. BetterThink agent selects the element whose sum of the offered quantities are closest to the needs in per set of offers. In this example, the quantities 2, 1, and 6 are offered. The element in the per set of that totals 6 is closest to the needs of 5, so it is selected. On the other hand, EpsilonGreedyAgent selects the element whose sum of the offered quantities do not exceed to the needs and closest. In this example, elements greater than 5 is not selected, and the closest set of 2 and 1 among the others is selected. For those who rejected offers, my agent makes counter-proposal equal to the shortfall. In this example, 2 units are missing, so 2 units are ordered. This counter-proposal is repeated until some of the offered quantity match to the needs. Finally, I'll talk about the evaluation. I simulated EpsilonGreedyAgent in 10 rows and 100 steps against Sync Random OneShot Agent, Better Sync Agent, and Random OneShot Agent. EpsilonGreedyAgent, my agent, outperforms those agents. Thank you for listening.